Good morning, everyone. So, my name is Kowtham Raj, and I look after the technology portions for Stack within L&T Green Energy Company. So, very good to be here. I think a lot of our colleagues in the DIAS covered the entire spectrum from policy to projects to even science. So, it's a very good spread. So, possibly I would give a brief introduction to our initiatives at L&T, what we are doing, and possibly spend 5 minutes on the product, which is possibly the missing piece in today's conversation. From the science to the projects in between, there is a product. So possibly that I will spend 5 minutes. So L&T is a large conglomerate. It's a $30 billion company working in many areas. And molecules is something which L&T hydrocarbons is being doing for many, many years. For the last 30 years, we built many hydrogen plants, many ammonia plants, many methanol plants across different parts of the world, primarily Middle East and India. So that's where we come from. Our strength and engineering already exists for molecules. We can do it very well, very safely, with extreme amounts of safety and excellence. But one of the new things that we did from 2021 is to start this new organization called as L&T Energy Green, which focuses on converting molecules into green molecules. So within this strategy, we have three divisions. One is in projects, another is in manufacturing, and another is technology. So in manufacturing, we have struck up we are focused on many different technologies, from batteries, electrolyzers, to even some of our hydrocarbon colleagues are working on biohydrogen technologies, methanol technologies. Our nuclear colleagues are working on nuclear hydrogen technologies. So it's not, L&T is not focused on one particular technology. Different groups are working in different technologies. So whichever technology which achieves scale, I think L&T will be in a position to contribute to India to indigenize some of these technologies. So now that I have given a brief introduction to the what L&T is doing, let me talk about products. Today's discussion is about green hydrogen ecosystem and accelerating green mobility. So this includes two products. One is a hydrogen generator, which could be many different technologies, as Dr. Guduru mentioned, and some innovative technologies. Even I was working in a startup several years ago, which uses completely different technology to produce hydrogen. But one of the common technologies is electrolyzers. For whatever reason, L&T has decided that we start with a traditional electrolyzer technology, but with some innovative futures. As Dr. Guduru mentioned, electrolyzers exist for a long, long time, for possibly more than 100 years. So one of the most oldest technologies is the alkaline technology. But the alkaline technology of 1900s and alkaline technology of 2020s are completely different. The membranes are different, the materials are different, the construction is different, and the way it is powered is also different. The original technologies are designed for hydropower, right, in Norway's. And even India had very large megawatt scale electrolyzers installed in India many years ago. So it's not very new for the country in a sense. But those products are designed for continuous, stable hydropower. But today the industry is different. We want to have electrolyzers with a little bit of flexibility so that it can fluctuate between different sources. I'm not even talking about renewable integration. That's the next level of challenge. Even within grid, within different sources, there are some sort of adjustments that we need to do it. So this technology is pressurized alkaline technology. Alkaline technology traditionally produces hydrogen at atmospheric pressure, but this pressurized alkaline technology, which everybody is nowadays a pressurized alkaline technology producer, including L&T with our technology partner from France. But also traditionally, alkaline technology is slower to start. This particular technology, which L&T is building a factory for. We are building a 1 gigawatt factory in Hazira in Gujarat, where we already have a lot of manufacturing facilities to build these electrolyzers. It can start pretty quickly. It can work reasonably reliably, but we are working continuously. As a lot of our speakers said, the technology has to improve. We have to improve. We have to get better. We have to get more reliable. So that's where the challenge is. That's what we are working on. Unlike most other the participants, L&T is investing in building a factory, investing in building people, building capabilities, training people to actually make almost 70%, 80% indigenous electrolyzer product in India, which is completely possible. It's not really challenging for a lot of organizations like L&T. We are very confident that we can make electrolyzers in India, but one of the challenges, the projects have to happen in India. There are other parts of the world. L&T is building is developing engineering for a 2 gigawatt hydrogen plant in Saudi Arabia. So those projects in the Middle East are going to happen, and L&T's electrolyzers will have enough demand across the world. But for our primary market is India. So for India to happen, the project has to happen. If the projects happen, of course, there will not be any dearth of electrolyzers in not in immediate term, maybe near future in 26, 25. I don't think there will be dearth of electrolyzers because companies like L&T are going to manufacture high quality, reliable electrolyzers at scale. That's what we are going to do. And there are other technologies, of course, as PEM, as Dr. Goodwin mentioned, which uses slightly complicated Nafion membranes, which has some regulatory hurdles, and it uses expensive materials. And there are other new technologies that are coming up, which is solid oxide electrolyzers. A lot of companies across the world, good companies, are working on them to use waste heat in industrial processes to increase the efficiency of electrolyzers. So there's real room for, there's a practical and it's very clear that electrolyzers efficiency is going to improve. There's a very clear roadmap. A lot of people didn't work on electrolyzers for the last 70 years because nobody really cared about improving the efficiencies because there's no real demand for hydrogen. Now that renewable prices have come down, there is demand for hydrogen. A lot of R&D is pouring into electrolyzers, so the efficiencies are going to go up. In next 5 years, I can clearly see a reasonable increase in electrolyzers efficiency and reliability. It's very clear. And the second part of the equation is for the mobility. There are many different technologies. Maybe for the simplicity and for time, we'll focus on fuel cells. And a lot of R&D in last 20 years, instead of electrolyzers, have entered into fuel cells. So that's the reason why fuel cells today are very compact, reasonably efficient, and also compared to ICE vehicles. And a lot of companies across the world do have high quality fuel cells ready for deployment, but there's not really a large market ready to absorb this technology because the electrolyzer technology is not efficient enough to produce cheap hydrogen. So that's a disconnect that the world had. They funded fuel cells more than electrolyzers. There are many more fuel cell companies than high quality electrolyzer companies. This is something which is very interesting. I was in Germany in March. I was again in different parts of the world, in Japan in August, early parts of August. I met many fuel cell companies. In fuel cells, there are 3 types of fuel cells. One is the most common PEM fuel cells, low temperature fuel cells, reasonably efficient, can work well, the kind of the ones which was demonstrated by Reliance and many other companies, Toyota of the world. And there is on the other end, high temperature fuel cells, 700 degrees Celsius. They are mostly focused on hydrogen generation for power consumption. They're much more efficient. The new technology is coming up, new products are coming, which is in the middle. Medium temperature fuel cells, which can handle even impure hydrogen, reasonably impure hydrogen.
Raj, have you got a presentation?
No, I didn't bring a presentation.
Then carry on.
Yes.
Carry on.
So it's a medium scale. It's a medium temperature fuel cells, which is also very interesting technologies developed as products by different companies across the world, which I feel there's a lot of promise because it uses impure hydrogen and are reasonably efficient and does not use any critical minerals. This was very interesting. So with this, where does India lie? In electrolyzers, at least, in all technologies, PEM, alkaline, AEM, in all the 3 major technologies, India has companies. India is building factories. So I don't think the technology is going to be a problem for India as such in this particular field, provided the projects come up in time and these factories have enough demand to continue to invest in innovation. So I think we are a little bit blessed compared to solar and batteries, where we are very late. The battery factories aren't here. The solar factories are mostly the replicas of Chinese factories. But in electrolyzers, we are reasonably ahead. We are at par with the world in terms of building factories in India. So maybe if the momentum continues, as Mr. Singla said, if the projects come, if the momentum continues, maybe it will be one of the few instances in our history where we will have an energy product indigenously made in India and we will not be reliant on imports too much. With this, I will close my speech and thank you so much for your attention.